Swayam Prabha. Digital India. Educated India.
As we move into the third part of our special series, the conversation around artificial intelligence in higher education continues to deepen. In this segment, our distinguished academicians explore more nuanced perspectives, from evolving teaching roles to interdisciplinary learning and innovation driven by AI. With fresh insights and real world experiences, this discussion sheds light on how institutions are navigating change and unlocking new possibilities in an increasingly AI integrated academic environment.
17 million people. This is how many lives that are lost every single year due to cardiovascular diseases. But many of these deaths were preventable. But in rural India, 65% of health centers lacked even a basic pulse oximeter. During the peak of COVID-19, we watched helplessly. Silent hypoxia took our loved ones because they couldn't access a single sensor. Health shouldn't be an impossible choice between a machine you can't find and a price you can't pay. Hi, I am Shivashish one frame at a time.
So this is the login page of a project called AgriSense Monitor. So we'll be like having the username and password here. So we'll be like clicking the sign in after entering our details. So in the dashboard, we'll be like having the total number of fields available, and with that, we will be like confirming which are the healthy fields available there. For example, in this, we have 5 fields which are healthy out of the 6. Then we'll be like having the vegetation index, which has been increased over 0.05 percentage in the past 1 week. Then we will be having the optimal range of the soil moisture, which is the soil moisture available there. Then with the help of the sensor of temperature, we'll be like having the temperature, and then we will be having the active alerts, which means the total number of alerts we'll be like getting. So this is like the overall summary we'll be like having out of the project. Then we'll be like having in which the recent field activity will be shown out of the fields, like the 6 fields. We have various fields, and the ratio will be shown here of the vegetation. So this is the system status, like how it is and what it is. Then we'll be like going to the crop health, which shows the overall crop health. This is like the futuristic crop health of future 2 years. And when we come down, we'll be like having the past 3 years record. So for example, you can have a look at here the corn field, which is like stress means which is like low. So we'll be like going up and seeing the same crop field which is in a good condition. So we have like actually increased the amount of soil crop health there. So so we have the overall vegetation index here, which has increased by 0.27 from the past 3 years to the next 3 years, and we have healthy fields and the risk. Then we will be like going to the soil data. When we come to the soil data, we'll be like using the soil sensor here, which will be like infiltered in the fields. Then it shows the soil moisture, the pH level available in the soil, the temperature, and the various chemical components like nitrogen, phosphorus, and potassium. So this shows the soil health recommendations, like what you should do next, and the recommended actions to prevent the actions there, and the nutrition status and all. Then we'll be like having the weather conditions here, where we'll be like monitoring the weather conditions. Like in this, we'll be using the weather API, through which we'll be like already concentrating and conducting the data. We'll be like having the current temperature present day. So this we can actually take it to the various places, and when we take it to other places, it will change automatically as per the places. So we'll be like having the current temperature there and the rainfall if it is present. So since there is no rainfall there, then we have no 0 mm. So the average temperature, the total rainfall, the humidity present there, the wind speed, how it is, and what kind of speed there is, and the visibility and pressure. So this is like the temperature trend. Like if we click it on, then it shows that what temperature we'll be having and what date, and it shows the minimum, average, and maximum temperature available. As well as temperature, we will be having the rainfall distribution here, where we will like shown that how much rainfall will be present on how many days. So this is like for 7 days data available here, and this is the overall view of temperature and rainfall. Like just like that, we'll be like having the weather insights as well. Like we have the irrigation recommendations, the weather alerts, like what should be done as per the weather conditions and the favorable conditions. Then we'll be like having the alert statement here, the alerts which are present, and it shows what and all the alerts and how the alert statement is. And based on the alerts, we can like do the things like what should be done and what shouldn't be done. And we have the critical actions to be taken as per the alerts, and preventive measures just to prevent the further worsening of the case. And the system health, which gets updated within every 15 minutes. And here it shows 2 minutes, which shows the recent updation taken place. Then we have the reports. So in this, we'll be like having the overall, just like how we saw the overview, we will be like having the overall summary of the report, and you can generate the report and download it. And as for the report types, you can download whichever, you can like separately download the crop health, soil health, weather, and alerts. Or you can overally develop and download the generate the report present here. Then we have the upload statement here, in which we will be using the data in a CSV file format. For this project, we have taken data from Google in CSV format and uploaded it and got the data in all this process. So this is our project.
Myself, Karthik, a second-year student in the Department of Electrical and Electronics Engineering, and in the college, Molecular Engineering College. And me, along with my friends, we have developed an AI-driven ascent system, ADAS, for unconstructed roads. So let me tell you one thing. Most ADAS systems work properly on well-structured, good roads, but most roads are not well-built or not well-structured. So we have developed an AI system that specifically works in unstructured roads like faded lane marks, and in poor lightings and sharp curves.
For lane detection, they use a model called YOLO B11. It helps the system to detect curved and broken lane lines accurately.
Our project uses several hardness. For example, the A model runs in Jetson or in Nano, and for the controlling and feedback is handled by ESP32. And we have developed the project using YOLO V11, and the project is developed in Python and especially trained in Google Pila. And then for the tools, we have used PyTorch, Keras, and OpenCV. Unlike the regular microcontroller like ESP32, which has a wide and Bluetooth support, we cannot run AI or ML in this. We can use tiny ML, but it's not that effective. Like we cannot run YOLO V11 models. So instead of that, we use Jetson Orin Nano, which is sponsored by our department, and it has 4 USB-A ports and an Ethernet port and a Type-C and a display port and a DC power supply jack. Okay, and this Jetson Orin Nano is LPDDR5 8 gigs of VRAM, and this can run like a large language model for which can be used for IoT purposes, and this Orin Nano can be used for industrial purposes, and it can run YOLO V11 and V8 and any large model you can throw at it. But even this Jetson Orin Nano has some limitations.
The system works well in different conditions like rain, fog, shadows, and even low lights. To understand the surroundings, we combine data from GPS, IMU sensors, and radar. This helps in detecting vehicles, pedestrians, and obstacles.
Artificial intelligence is rapidly transforming how we learn, work, and interact with others. While AI adoption is rapidly increasing across industries and education, its benefits are still unevenly distributed. For many visually impaired individuals, basic tasks such as navigation and social interaction depend on external assistance. This demonstration shows a real-world scenario that highlights a gap where AI can play a meaningful role.
Hey, what happened, bro? I am visually blind. I have something for you.
Srinath is in front of you.
VisionX is an AI-powered assistive system designed to provide real-time voice feedback to visually impaired users.
Someone is coming towards you. Car is going from your side.
By combining artificial intelligence and computer vision, the system helps users to understand their everyday environment.
There is a pothole. Walk carefully. Rickshaw just passed away.
Beyond physical navigation, a major challenge faced by visually impaired individuals is social confidence. At the system level, VisionX follows a modular architecture. An ESP32 cam continuously captures visual input from the environment. Each frame is processed in real time using AI models to detect objects, people, and spatial context. The processed information is then converted into concise voice feedback for the user. By identifying people and giving contextual information, Vision X is a much safer and confident social interaction. A key design principle of Vision X is offline first operation, where the main roles such as face recognition and object detection does not require internet connectivity. This reduces latency, provides privacy, and ensures reliability in low connectivity environment where blind individuals can travel safely and effortlessly. And when a person is detected, face recognition is performed using FaceNet, which compares the faces with previously stored embeddings in locally on the device. If the person is unknown, then it stores the face on the device. This enables recognition of a familiar individual without transmitting sensitive data externally. User safety was a central consideration during development. Vision X is powered by a rechargeable lithium battery, also with an integrated protection circuit. In the event of short circuit, uneven control flow, or abnormal current flow, the protection IC automatically cuts off the power, which saves an electrical hazard. The device can also be charged using standard mobile charger, which ensures independence from a specialized charging system. Also, the smart glasses are designed to be modular, allowing future extensions such as video calling assistance and a lot more. VisionX demonstrates how a student-led AI innovation can translate into real-world social impact. By focusing on inclusion, safety, and responsible AI adoption, this project reflects a role of higher educational institutions in building a project for social good.
What if you are trapped under the ground, unable to move, unable to call for help, with every second reducing your chances of survival? Imagine an offline AI-based system could detect your presence within the golden hour, which is the first 72 hours after an accident, not by chance, but by intelligent analysis. Even when a person is trapped underground, they don't disappear. Their movements create vibrations, and by vibrations, I mean the strings of a guitar producing a particular pattern. The same goes for a human movement. So it generates a unique vibration signal in the ground, which can be learned by an offline AI model. So how we'll be detecting the vibrations, it is completely dependent on. We'll be using a probe to insert into the voice. Once the probe is inserted into the voice, it will be analyzing the human vibrations, like it can be a heartbeat, can be a tapping sound or scratching, whatever it is. Once the human vibration is produced and passed to the centralized system. And what the centralized system does, it has an offline AI model, which is particularly trained with datasets like heartbeats, tappings, and scratchings. And we have particularly used random forest model. And the reason we have chosen the random forest model is it can give us a better accuracy and result with a lower number of datasets. Plus, we have used the synthetic datasets for heartbeats. Once the detection is done, the indication is done by two methods. The local indication is given on the probe itself, which has a buzzer and an LED. Once it is done, plus we will be getting centralized indication, and which will be like there will be a navigation route for the probe itself. A single probe can cover 5 meters. Imagine if a probe can cover 5 meters of distance, we could be using 10 probes to cover 100 meter radius. And this is not even just a budget of NPTEL. We can manufacture 1000 probes with just 0.1% of the India annual budget. What if someone close to you, maybe a friend or family, and let's say P3 provides a solution to identify them, would you save them or not?
Our project title is City Connect, a centralized digital transparent platform for city-based services. So modern cities, they rely on multiple disconnected platforms
first, this is smart sugarcane quality analysis. First, we are using can identity. We can select the can variety, which variety we need. For example, I am clicking early spec, and the can age also we can mention. Anti-gravity AI helped us to make a complete project.
Our campus doesn't just teach
various AI tools in the market right now, and we all are using it. And talking about my project, which I have made through AI, is this form. Here we are seeing that this placement attendance form is made through AI. Here we simply place our data, and these data are calculated into the Excel sheet format. As I am a video editor, so I basically use these AI tools to generate various images. Like this is our college campus. Here I simply give him a ChatGPT a prompt, then it simply changed my campus to this AI university, and it's a futuristic image. This is my original image of the campus, and after giving this prompt, it simply changes it into the AI driven university. So as we all are aware that there are also various AI videos circulating right now in various platforms, and through this Gemini helps us in this generation of this image. We simply have to give this prompt and to VO, and they simply generate it. As we are aware that I have given it a prompt and it simply shows a video. Here is this video.
That solves the scaling issue.
So these videos are generated through with the help of AI. So basically AI is circulated in market and our campus is ready with AI. Thank you, wishing you all the best.
Hello everyone, my name is Achal Singh, student in Institute of Technology and Science. AI enables machine to learn from data and recognize patterns and make intelligent decisions. In our campus, it is not just a subject, it It is used in everyday tools and projects. Thank you so much.
Artificial intelligence is no longer the future. It's already part of our everyday campus life. From classrooms to creative projects, AI helps us learn better, build smarter, and turn simple ideas into real innovation.
I am a diploma IT student from the IIT. And my name is Vidhi Patel. I am a diploma IT student from IIT. And our topic is sentiment analysis. Sentiment analysis is an important application of artificial intelligence. It uses AI-based techniques to understand opinions and emotions from text data. It commonly used AI-based applications and tools like customer analysis, reviews, and social media posts. The system first takes the input from predefined data set, which is cleaned and pre-processed to remove unwanted or irrelevant information. After pre-processing, important features are extracted from the data. These features are further sent for model training and testing. Once the model is trained, the tested information are used to generate output. Few applications of sentiment analysis are customer feedback reviews, feedback analysis, social media postings, brand reputation and management, politics analysis, and such other data. This graph shows the sentiment trend of messages analyzed using trained dataset. On the x-axis, we have different messages, and on the y-axis, we have different sentiment values. Here, 0 represents negative sentiment and 1 represents neutral sentiment, and the other second represents positive sentiment. We can see that sentiment moves from negative to neutral and then positive, which the overall feedback is improving over time. This is how AI and ML based sentiment analysis help us to understand opinion manually.
Wine quality is important for customer satisfaction and brand reputation. Traditionally, wine quality testing is done manually by experts, which is subjective, time-consuming, and may vary from person to person. To overcome this issue, our project uses machine learning to provide an automated and data-driven approach for wine quality detection. We used a red wine quality dataset that contains real wine samples with their chemical properties and quality ratings. From a technical point of view, we first load a dataset into the system and platform data pre-processing. This includes cleaning the data and preparing it for model training. Now my friend take over the presentation.
Good morning everyone. Continuing from that, machine learning helps our system to learn historical data and make accurate predictions. We use important chemical features such as acidity, sugar, pH value, sulfates, and alcohol content as input to our model. These features help the system understand how chemical composition affect wine quality. In the technical flow, after pre-processing, we split the data into two portions. One is technical and the other is training section. Then we train our machine learning model with such algorithms which are k nearest neighbor, linear regression, and k means clustering algorithms. Finally, the trained models are used to predict wine quality and evaluate performance using accuracy and error metrics. This complete technical process ensures reliability and consistent wine quality predictions. Now the applications of our project is production process optimization, wine industry quality control, cost and time reductions.
Now I would like to conclude our presentation. What did we get by making project? Automated wine quality prediction achieved. Reduce human efforts and bias, improve consistency and accuracy, useful for wine industry quality control.